It all started with what I once released as shiny components. That's when I was going back in the commit history. It was from the 1st December in 2018. So just a little bit more than 3 years ago. So um, I didn't change anything on this side, but I continued working on this one just for some internal things. And then at Emberfest, because Jay had this nice talk about design patterns and Ember, and I was like, that immediately got me. So I was for myself, hey, I need to learn that person. I need to get to know him. So bit away from the mouse. So is that a bit better? I hope. Um, and so I was like, okay, I need to get to learn Jay and show him what I got. And so I want to see how the things are coming together. So as this is from a bit more than 3 years ago, and I still worked on this, so there's quite some information that was coming together over the course of time. So here's a bit of a manual for how to process the information in this talk. So first of all, when I showed this to Jay, he said, well, why are you keeping this hidden? There's so much good things in there that I could use that would help me. And so remember that there's always something new for anybody in here. Also for the others, it might just be trivial knowledge. So that's a great thing to keep in mind. And I think that's a phrase that got me. Um, so I want you to get an overview of what is available. Maybe to recognize there's different perspectives for things that you already use. Um, I I as well have some practical tips at the end as well, so to get you started. And one important thing, just do not overwhelm you with yourself. Let it sink in. Like, let that be a stream of information. If you don't make sense of it right now, just let it pass by. Take reference. Hey, okay, this is something that Gossi was speaking about. Maybe I need to know this, and then I can come back to this. That's exactly the mindset. And fun thing is, all of this is basically framework agnostic. So I think what you learn here is what you can also apply to different frameworks. It's just happening, or like by surprise, that we are at an Ember mini conference. So I have the examples written in Ember. Ta-da! So what was the goal of this? So I made this component specification template. You can see this is just a blank, empty square for now. And over the course of this talk or talks, we're gonna fill this up. So some vocabulary up front as I want to use them, and I think it's good to have a shared mindset or shared understanding of the words I'm using. So we think about inside and outside for some situations. Inside is more that we inside is the perspective from developers and authors of a component, more on a definition level, and then the outside view to a component is when we are consumers to those components and when we want to invoke them. So we can be inside and outside at the same time sometimes. And then the second thing is internal versus public. So sometimes internal refers to as components within components. And they should only be known within that scope of the outer component. So at the moment, Ember has a global resolver, but soon this will be changing. And so the internal components are like the purpose of them that they are only consumed within that scope. And the public components on the other side, they are publicly known and everybody is allowed to use them. So just as a starter, let's go into what we want to cover today. So there's 6 sections. The first one is haptics, then patterns, then types, classification, styling, and then finally putting this into practice. We split the talk almost in half. So for this slot, I will be speaking about haptics and patterns, and then types, classification, styling, and putting this into practice will come in the second slot towards the end of this conference. So if you want to remember one slide from this talk, it's this one. So there's component architecture and there's 6 boxes to it, just by the name, and the contents are for now I think a bit empty, and we fill the contents over the course of this talk, and by the end I hope that you can reference all of the names to some of the contents that will make this up. All right, so let's get started with the first chapter. It's about component haptics, which is more on how to interact with the component. And for this, let me introduce you to Bob and Greta, which will be my mascots for this talk, and help me to introduce each chapter to you. Now, on the left, we have Bob, the mini, and on the right, Greta, the bully. And for the haptics, it's like how we touch it. How can we like interact just from the first interaction, from seeing it? How can we interact with the cars? Or in this case, can we get into the cars, and where can we put stuff into the cars? And like if we look at this, so then we can open the doors and say, okay, this is our entrance into the car. The mini, you can enter through 2 doors and 1 trunk to put some luggage in, whereas on the bully, we have more doors, and of course we have more room and space to put some luggage in. So that's just the first difference. It's more like how you can interact with that. And I start with the definition for each of those sections as I see it. And haptics indicate to a consumer how to interact with them from the outside and signal the mechanics to plug and play them together. So some of the plug and play characteristics that we have. So thinking you want to put some components on your page, then we might think about them. Hey, is this component I'm using, is it styled? Is it intrinsically styled, or does it leak some styling? So will it cause trouble to my layout I'm injecting this component into, or is it safe to use this component and my layout can continue working as is? Second thing is, does it contain some content? Like, does it write something in form of letters or words onto the screen? So does it contribute to the information we're seeing? It's more like a Boolean thing. Does it like have this, or doesn't have it? Like maybe it's a renderless component instead. Also, content would be something like pictures or so, or media elements. And then third is structure, which is, does it like provide some document structure for layouting purposes for the child elements that we put into these components, or does it come with like a layout itself, like some card or rectangle in this given style, just to make up a given design, and then we can put stuff in it. So, and then also is the invocation of a component. So at first we have an inline invocation where we have, in this case, a button, and then we pass a label to it, and we call it a day. The second example is a block where we do not use this inline invocation. We have an opening and a closing element, and in between we have some content that we can put into. And sometimes, we also have this mixed situation where we have arguments in which we use to pass information as well as the block element. So for the third case, is actually what's going on. What is this button going to show? Is it showing the add label, or is it showing the block, or is it showing both, or is it like, hey, I have both, I quit my job? So just a couple of things to keep in mind when designing your component APIs. Next is blocks. So on the first example, we have an opening and a modal and a closing modal element, and inside we have some content. That is the implicit way of using a block. We can have the same example by going explicit if we use the colon default name for name block. but usually we don't do this for default, but it works. And if we go by explicitly naming the blocks, then we have this colon header, colon body, and colon footer blocks that we use for the modal if we wish to use them. So also two blocks are the block params. They come in as an with the as, and then inside of the pipes we have access to the names or to the parameters that are given to us, and we can assign them to the name we want, and later on we can use them. So in the implicit default block, we have them on the component element itself. On the explicitly named blocks, we need to specify that on the named block invocation. Contrary to blocks, to actually push information from the component, from inside the component to outside, we have the access to, or we can use yields. So here we have yield, then the information, the parameters that we want to yield, and then we can also specify to which block we want to yield them to. So there is actually a great explanation to yields from Dan Freeman, which I want to pass on. It's we have the modal here as written as in a JavaScript generator function. We have the root element that we create. Then we have the header, body, and footer, and then we yield them. So we temporarily give back control to the consumers of this generator function. They can like modify them as they wish, and then when we get them back, we assemble them, and then we return the modal. Like it helped me, maybe it helps some of you as well. And then we can also have yielded components. So the yield here can take a hash helper. The hash can then push out a key value object. We can have the same close method as we had before, but we can also yield components using the component helper. And then from the outside, we can have access to the yielded body component that we can invoke from there. As we have down here, so we have the modal, which is the reference to the whole yield hash, and then we can invoke the model.body component that the author yielded to us and give us for a thing to use, a specific component to use. So if we put them side by side, we have named blocks and yielded components, and sometimes it's a bit confusing of what they can do and what they should be used for. So here's a summary of them. So for named blocks, they can only be one block and one named block. They have a dedicated area, so to say. So basically, a named block is, okay, here I pass in some block level information, and then it's up to the component to decide where they go. As many think this has to be in a combination to an element that the component is using inside. That is actually a myth. So most of the time we do that, but it's not the idea of it. And as a matter of that, named blocks do not take attributes, they do not take arguments, and we can also not conditionally wrap those blocks. So we have to put the conditions inside of a block if we want to use them. And basically, the author of a component is in control over providing this API. On the other side, we have yielded components. We can have multiple invocations for them. They are in the spot that we invoke them at. And of course, they can have attributes, arguments, and we can conditionally wrap them if we wish. So it's the consumer who is in control over them. As a discussion, which I have on the end of each of those parts, the syntax I showed you is definitely Ember specific. There is an RFC, the component signature, which talks a bit more about how to document those and actually how to maybe get IntelliSense for it when you use and build them. But the naming can differ between frameworks. So maybe use named blocks. I know in Vue it's called slots, and other frameworks may use different names for them. Or we use the same names, but then we have a different meaning. So that's just a thing to watch out for when you speak to other developers or peers that are coming or have a different background in other frameworks. So for the component specification template, here is our first edition. The elements, arguments, and blocks go to the signature as per RFC. And then for the haptics, we can say that we have style, content, and structure to it. So if we want to describe a component through that template, we can say, yes, we have a style given, we have content given, or we have a structure that is coming with that component. And that concludes the haptics of a component. Um, let's go into component patterns. It's more like how they work inside. So for this, let's go back with Bob and Greta as they tell us what they are for. So in this case, this is how the components work inside. So it's part of the engine. And of course, when we want to understand how a car works, then we need to lift up the HUD and need to risk a look under it. And basically, if this is the same for our components, so we look inside them and see how they are working. So the definition goes as this: that patterns are part of the engine that powers a component. And the motivation for this is by the book Design Patterns, Elements of Reusable Object-Oriented Software. The book was written in 1994 and still stands the test of time. So I had this book and I was like, okay, how can we implement the design patterns actually in a declarative way? So the examples in the book are coming from object-oriented programming. The examples are written in C++. And so I wanted to know, how can we actually do that in a declarative way on the templates themselves? So the component patterns are structured or grouped into creational, structural, and behavioral patterns. The bold ones are the ones that I'm gonna cover for this chapter, and it's worth to mention that some of those patterns are actually so good that they find their way into the language itself. So we do have a proxy inside of JavaScript already. We maybe have the decorator in JavaScript soonish, like fingers crossed, right? And so like other languages also adopt them accordingly. But for this talk, I'm gonna go over the bold ones. So the way I'm doing that is I explain them in brief, then have a usage example at which we can see and learn and understand this, and then finally how to apply that in some situation. So first is the group of creational design patterns. And the purpose of them is that they abstract away the instantiation process of a component. So they make the system independent of components and how they are created. Now you need to think about, go back a little bit in time. So when the book was written in 1994, the object-oriented programming was the most prominent one for this case of for this use case. So this was the reference in terms of language level. So they only had to compare against the inheritance in this object-oriented world. So and when the book was coming in, it was like, okay, with the creation and design patterns, we go away from inheritance and we want to delegate the instantiation. So they favor composition over inheritance. Just to give a bit of background here. And the first one is the factory component that we want to look at. So it's about creating families of related or dependent components without actually specifying which of these concrete components we want to invoke. So, and the example is here that we want to build a form and we actually get the fields from a backend. So we do not know in the front end what kind of fields we want to create. So at first is the way how it would be done in object-oriented programming language. So we have a control factory that has a static create control method. We pass a type, and then based on the type, we return a text or number control for this short example here. In template label, on the template, we would use the component helper. We concat the control and then the add type that we pass into a component. Then we have this as a control, and we can invoke it when we use the let helper to assign this into the control variable. And then in the invocation, we have the control factory. We pass add type text, and basically then we have the component control slash text that we are using. I think that's what many of you are already doing in one form or the other. So it's just as simple as that. So when we want to use that is when we actually can't anticipate the concrete component, so some dynamic form here. Or we want to have the system to be independent of how its component are created, composed and represented. So we do not want to have a concrete implementation sitting somewhere. We want to have this parameterized and controllable from the outside. But we also constrain ourselves to actually only a family of certain components. So the control factory should only create control components for us, but no more, nothing else. And then another example or another interesting point is that we want to keep the implementations private and only expose the public creation. So in some forms, this is really helpful if you want to use that. But there's some caveats with these with the factory components. So in the classic Amber world, we would use the component helper. We concatenate an argument with some namespacing here, and we're good to go. In the embroider land that's about to change, so Ed and team were writing a markdown file like replacing the component helper that has a lot of instructions of how you can use the component helper in an embroider world to actually make use of static analysis and then later on tree shaking. And in the future, there's RFC 779, which is about how to import components. And then actually we can use the OOP method, the factory method in our components, and then use the created component within the template. Next one is the prototype component, where we can specify a component by copying or cloning the specific instance into it. That's a bit of complicated perhaps to understand. So and it has a very specific use case, and this is also up for interpretation of how you want to see that. But the example I'm going to show you here is that we want to build a profile for various different stormtroopers. So I think stormtroopers are great because they are originally cloned in the system of Camino. So we're kind of playing the Clone Wars here by cloning components in. So I gave a little bit of a visual here. So we want to build a trooper profile component. We pass in the trooper, and then based on the trooper that we pass in, we want to give two different screens with like kind of different look and feel or behavior onto it. So in the object-oriented programming world, we would have a stormtrooper and the heavy trooper profiles. Each of them has a show method and is passed in a trooper. And then we, inside of that function or method, we compose the profile screen. And then we have the trooper profile, which is like the entrance to it. We get the trooper, we see or we check which trooper we have, and then we clone the respective component into it. So which is in this case represented as the object.create, which if we desugar this, then we would have a function, and in the function we will set the prototype to what we pass in here, the heavy or the stormtrooper. And now we can use that. We have Finn with our number and name, and then we make the trooper profile with Finn, and it would find the what kind of trooper Finn is, and then would like clone the respective profile and show it. If we would do this on a template level, we would do it quite the same way. We will have we would check for which trooper we have, and then based on this we will invoke the component, and we store this in the profile variable, and then later on we can show the profile on with the trooper that we passed in, and we can invoke it as trooper profile and pass in the trooper. So basically we clone in the respective profile given the trooper we have. And how we can use that also for similar to the factory pattern, component and pattern is when the components are specified at runtime. But it works better when there's only like a few combinations of components available in comparison to the factory, which like works with any amount of components. So when we have only a few sets of components, then we can avoid these heavy usages of factories. And that's it. So we get to the next one, which is the builder component. Build is a creational pattern providing a construction code that we can use to produce different types and representations of a component. So it's like giving us a kit, and then we can play around with that. So let's make a card builder and compose different cards. At first, we're gonna have a look at the object-oriented programming. So here we have a interface, the card builder, and then we can say, okay, we have a build header, build body, build footer, build image, and build list. And when we have all that done, then we can use get card to get the final structure. Now we have two implementations of that interface. One here is the material card builder, and the other might be a bootstrap card builder. So different frameworks, and then maybe they have different APIs. So both of them implementing that. So let's use the material one to build a simple card here. We use the material card builder, we build a body, and that's it for the card, and then we get it. Now, for when using the bootstrap build in this example, we build a header, we build a body, we build a footer, and then we get back the card. So classical dialog that many of us use already. So how would that be in a template? So here, this is the card builder component, and here we use the yield and a hash helper to yield out a body, a header, and a footer component. That's like the kit that we yield out, and then we can use that. If there's no block params given, then we just fall back to the body only. So it's like the simple and the more kit usage that we see in OOP before. And then the usage is that we want to have a component, but it must allow different representation, different combinations of how we want to use that. We want to have complex components. And we want them to be independent from the parts of how they are assembled. So we want like a builder component is great to have this as a layouting or a kit component, and then we use our our concrete component that is using the builder to build the actual component that we want from him in the parts that we want. For us in Ember, there's specific where we want to use name blocks or we want to use yielded components. So just look what is the best in this case when you are about to design such a component. Next is the group of structural design patterns, and they are concerned with how components are composed and assembled to form larger structures. So how we put multiple components together. And the first one here is the decorator pattern or component, where we attach additional responsibilities to the existing component. So here's a very custom decorator. We want to add some special styling to a specific component. So this is the template for a fancy button. It uses the button and it puts a local class, a fancy local class to it, which takes over some additional styling. Now, it adds a little bit of decoration. It adds a little something, but this component itself is not really reusable because it's bound to the button that we use here. We can also make reusable decorator components where they attach a concept to any component. So here, this is a scrollable decorator component. We take in a component as content, and then we add a class scrollable to it, and then we yield it back. So this is an agnostic concept, but we cannot re-export named blocks if there is named blocks available for the component that we pass in as add content. So as a result of this, the reusable decorator components are fragile, and my advice would be to better not use them. Just want to highlight them, that they exist, and if you see them in the wild, please keep that in mind. Then stylish additions may also be good to have them added through your CSS architecture. But the important thing, the important takeaway of that, adding a little something to any existing component is kind of a decoration. So you might do this as part of your existing components to add some additional styling, to add some additional behavior to it that wraps the existing one. So when you do that, be aware that this is kind of the decoration to the existing component you're using. Custom decorators or custom decoration components are, on the other hand, a great thing for maintainability, as each of these components is responsible for the thing they are adding. And this goes nicely with the single element pattern by Diego Haas. So think about, you have a component that wraps a component that wraps a component that wraps a component. Now, if each of those components would add a div to the DOM, then we would have like a div in a div in a div in a div, but we want to keep that to only one element, whichever it is. So, and he suggests that instead of making a component with multiple arguments, he said, it's better to have a fleet of components with actually almost to no arguments. And each of these components has its own responsibility. So if you need to change something, you don't need to look through your armada of arguments and see how they possibly have side effects, but you can just focus on the one component. I think there's sometimes the feeling that having lots of components is super overwhelming, but it turns out, according to my experience, that having like components with a specific purpose is actually really well for your maintenance. So it's perhaps something some of you need to maybe become comfortable with, or think about becoming comfortable with, to have that armada or fleet of components. So the next one is the adapter component, which actually converts two different interfaces and that are incompatible to each other. So you can have one component that takes one interface and then it connects to another one and does some transformation in between to do that. So here is a button component as an example, and depending on which kind of UI library you were using, may it be Material Design or Bootstrap, then this button component like adapts to each of those systems or to each of those libraries. So there's a different API for the Material Design button as well as for the Bootstrap button. So it manages to pass the arguments from one component to the other. The usage is quite that we can connect two components that actually do not match. And that's one thing here is that you can, when you are working on a new version of a component, then you can create this new version of the component in isolation in a new field. And then later when you say, okay, I have the new component ready and your existing code is still using the old one, then you're turning the old one into an adapter component, like doing the transformation to the new component we created, and you can actually migrate over to your new component without impacting the existing production code. So that also means that you sometimes want to use this pattern if you see that there are some components coming in that you can't foresee, and you are then wise to use the adapter pattern up front. So the practical example, as I already outlined, is migrating legacy code to new code is perfectly suitable through adapter components, just as I explained. And another practical example I figured is for a way maybe helpful to add-on authors, where you are about to developing a new version of your component that has a completely different interface. So you make a new component in your add-on, you turn your existing one to use the new component under the hood. You can even throw in deprecation warnings and say, hey, for the next major release, this component will be gone, so please use the new one. So just a way to use those adapter components. Hope this is helpful. Next one is bridge components, where we actually decouple the abstraction from its implementation. And then we have a chance to actually vary the two of them independently. So the example I thought for this is that we want to make a modal component that is actually different on desktop and mobile. So here's how that could be look like. So we have the modal component, and left is mobile. So we have this as a sheet, and on desktop we render this as a dialog. So just a way to say, okay, we have the modal, but we have two different implementations. How has this been done? We are checking in the modal itself whether we are on mobile or not. If we are on mobile, we're using the sheet component. If we are not on mobile, we're using the dialog component. We store this in the modal variable, and then we can use the modal based on whatever it is, depending on the environment. So we can also replace the modal with like specific modals, like whatever, maybe an alert modal. Don't know, maybe a little UI gimmick that says, hey, you really need to take care of this, or also muted modal, which is a bit more subtle in the way it pops up. And also another example is how we can basically reuse this is if we exchange the modal to a dropdown, and then we say, okay, on mobile, this is actually good. We continue using the sheet, but on desktop, we might want to use combo box style pop up or container that pops up right next to the element that triggers this this content or this drop-down box. So it's quite versatile. So we can exchange the implementations on the lower level, and also we can exchange the higher level like drop-down based on what we need. And you see, in this case, it would be nice to have a like good API amongst all of the implementations that can work for the like actual implement, like sheet, dropdown, dialog, as well as on the abstractions like dropdown and modal. Okay, how we can use that? We can avoid a permanent binding. Like let's say we implemented such a modal and we use the sheet class directly, and then we want to go onto desktop. It's like, oh, on desktop now it's showing up as a sheet. which is not expected. So we can use the modal up front, and then it resolve to whatever component we want to use as the actual implementation. We can also use that when we want to hide the implementation. So we maybe want to give out the modal component, but the consumers of our modal component do not need to know how this is handled internally. And also we can have contextual implementations of that abstraction based on in which environment we're in which context we're in, stuff like that. The next one is the facade component. It provides over the unified interface to a subsystem. So with the unified interface, we will then have an easier handling of the entire subsystem that sits behind this. For this, a nice example I've seen is that we can have a screen or a page component for, in this case, a product details page. So how does it look without the facade pattern is here we are in the route of product/details. We will have a header section, we will have a specification section, and maybe a price section for product details. We pass in a product to each of those sections, and then some sections receive specific links. So the header section is receiving an overview link, and the price section is receiving an offer link. Now, how do we turn that into a facade? Is we on the route level, first we remove all the sections and say, okay, we go and invoke the detailed screen component, which is the facade. We pass in the product and we pass in the specific links. And then inside of the detailed screen component, we route the arguments that we are passed into the respective sections. So overview link still goes to the header section, and the offer link goes to the price section, and each of them is connected with the product. So the usage is that we can provide a simple interface to an actually more complex subsystem. And like the screen, like the product detailed screen I showed you above, is only about 3 sections, but if there are more and more and more added, that might be getting more and more complex. Then the facade can also often act as a default view, where we can use the facade and say, okay, that's good enough for what we want. And if we need to look or want to make customizations, then we need to look behind the facade. We can also decouple the subsystem from clients or consumers and other subsystems, so we can have them separately, and no need to always deal with the individual ingredients of such a subsystem. And we can also use this to promote subsystem independence and portability. Like think about the detail screen we had above. We can now use this screen and move it from, for example, one engine to another engine. The routes might be different, named to each of those engines. And then each engine can invoke the screen component and pass in the respective links that we get through the engine interface. Yeah, so the facade, as already said, is an entry point to our subsystem, and we are safe to sometimes rearrange behind that if the facade is the only thing we make public. So then we are going to the last group of design patterns, which is the behavioral group, which is concerned with the algorithm and the assignment of responsibilities. So more patterns, how the communication happens between different behaviors. And we can characterize complex flows that are actually difficult to see and follow at runtime. So we can abstract that away, so we have that easier and better to maintain. And we shift the focus from the flow of the control to actually how things are connected. So the first one is the command pattern, which encapsulates a request or an action or a transaction. And good thing is I made something here already. So you can use Ember command as an Ember add-on. You write your command as a simple class that extends from the command that's provided through the add-on. Inside of the execute method, you provide your business logic, and then you use your component to connect it to the command, and that's it. So you move the business logic from the component to the command, and then you can connect the command to different situations, to different components, and that's it. So we have like encapsulated that one business functionality inside one unit. And like I'm doing this, I often found myself that the execute is just a one-liner, so that's not that much of code that is living in there, but can be growing bigger and bigger. So the usage is that we can separate the business logic from UI. We can connect the command to different locations. Like according to the book, then some of those commands may have an undo operation. So think about you doing 3 actions in your UI, and then if each of those would have an undo, you can go back, you can revert the action for the customer in if they wish to do and like use the go back functionality. That helps if we keep track of the commands in history, saying, okay, you have now executed like these 5 commands, and we can go back in history by undoing each of them until the point where you're comfortable again with whatever you are seeing before. And we can support transactions, so a set of commands. That's the thing I really love about this design pattern is you can have a command that consists of multiple commands, which means that each of these like atomic commands is only responsible for one specific action. But you can compose them together saying, okay, I want to do this and this and this. And in the next location, you want to only do 2 parts of them, but not all of them. So each time you connect them to a UI, you can say, okay, this set of commands I want to execute. And on another UI location, you say, I want to execute a different set of commands. Really, really powerful and helpful to compose them together. Next one is the strategy pattern, where we define a family of algorithm, encapsulate each one, and we make them interchangeable. So here's the example about product card variants. So think about we running an A/B experiment and we want to test which of those cards that we're testing is performing better. So how do we actually do that in code? In terms of different UIs. So we want to have the product card, and we have the add variant argument that we can use to pass in a different component. And in this case, we check if we do have that with the OR helper. And if we do have the variant passed in, we can use it. If not, we use the component helper to fall back to our default card. Now, how to use that? We use the product card. We check if we are in the treatment of our experiment. And if we are, then we pass in the component card experiment/treatment component in this case, and our card can use that. So there's a functional solution to that. So it's the same as above, just written in functional form. So we have our default variant, which is just a function. We have the product card, which can take a variant as a parameter. And then we have, we check whether we are given the variant, or if not, we fall back to our default variant. And then we store this in the card variable. So, and then later on, we define our treatment variant, and then we can use our product card and pass in the treatment variant. Now we're leaving a bit the object-oriented programming for this example, but I think you are maybe aware of this already, because this is what is been called as or referred to as high order functions. So we can pass in a function into a function into a function, which is what we're doing here. So we can like then use this to make high order components where we pass in a component in a component in a component. And this is just the way it's been looking and here in the function and solution as well. So you can kind of see the difference or compare the similarities between each other. So the usage for that is we can use strategies to encapsulate different behaviors that we want to show. We can use components as strategies to provide different looks. So the looks are interchangeable. And we can use the components in combination with the builder component. So the strategy components we pass in are using a builder component on as a backing up kit to make these strategies. So we can like ensure consistency amongst the variants. Then we use those components and pass them into the UI we want to see them. And we can then also realize behavior through other patterns, like we can use the command pattern as a strategy that we can pass into components. So we have them customizable from the outside. And a nice other thing is that we can avoid conditionals. So we pass in the add variant component from the outside to our product card and do not have if else within the component to check for like plenty of possible variants that we want to run an experiment for. So it's a nice way to reduce this and see where it's actually coming from. So that is the design pattern. So final discussion here is a question from me to you is, are you maybe already using a pattern and without knowing it? So maybe you just learned something or some naming for what you're using. Are you then better able to spot the scope of a technique and a component that you are either creating or are about to change? So when you're reading a different person's code, do you agree or disagree with my interpretations? That's I would love to hear then. And are my examples hitting the intention of the design patterns? Or maybe you have different ones that say, hey, look, this is something that would make it clearer for me. Would also be interested to know. And then important thing is that design patterns are nice addition to our toolbar we have available to create components. So they make a nice addition. And then how we can apply the design patterns. First of all, use them reactively, not proactively. Do not over-engineer from the beginning. When you see something that when you like getting too much code in and say, okay, now it's becoming a bit unmaintainable, a bit unmanageable, then it's a good way to think about which kind of design pattern, component pattern you can use and then apply it. And an important thing is that you should not be using any technical language. Like, do not use add strategy to denote this is a strategy pattern you're using. Please use your domain language according to what you're working with. Do they actually solve the problem you're facing or not? And sometimes it's like the design patterns are not here to be used for the purpose of using them, but they are here to help you when you are seeing the need for them. As I said, yeah, please use the right tool and do not abuse the design patterns for things they shouldn't be used for. So let's go back to our component spec template we had from the last time. We see signature and haptics are there as is, and now we're going to add the design patterns in there. So we can say, if we want to use that template to describe a component, we can now say, okay, see, this component is using this and this and this pattern, or another one, or none of it. All right. So this is part one of component architecture. We had haptics that is more about how you can interact with the component from the outside. And then we have patterns, is how the components are working inside. That concludes this part, and we make a pause